Hey guys, and welcome to the first video in the kind of CIE A Level Maths video series where we're going to be covering all of the pure content. So this is starting off with the quadratics in paper 1 with completing the square. But before we get started, really quickly, I'm offering free tuition lessons for CIE A Level Maths. If you look in the link in the description, there is 2 Google Meet links. One is for Wednesday between 7 PM and 8 PM London time, and the other one is for Saturday 3 PM to 4 PM London time. It is literally just a free, you click on it, you can join the lesson, and we can take part in some free tutoring where I'll go through kind of one topic every single time we go on it. So it'd be the same topic on Wednesday and Saturday, just so you know, but we'll go through some of the harder exam questions. So if you're interested in joining, just save that link and join on Wednesday or Saturday, or both if you want. So, completing the square. Completing the square is when you change the form of a quadratic from this form here into this form down here. And it's basically just a formula that you need to know. So let's just apply it to a quadratic so you can see what on earth I'm talking about. So if I drag this down to the first question, here's a very typical exam question where they can just ask you to write this quadratic in the form x plus a squared plus b. This form here is called completing the square form. So let's do this. So we're going to have, applying the formula, we're going to have x squared minus 6x. So now we're going to have x, and then it says plus b over 2. b in this case is negative 6, so divide that by 2 is negative 3, so it's minus 3 squared. Minus 3 squared. Make sure you put this in brackets because this term here will always be negative no matter what. If you put the negative on the outside, then you're going to get something a bit weird. And then plus the number on the end, so plus 1. So that becomes x minus 3 squared minus 9 plus 1. And lastly, x minus 3 squared minus 8. And that's it, and you normally get around 2 marks for that. Now part B is a little bit more interesting, because what is the point in this form? Well, first of all, you can solve quadratics with it, which is pretty cool. But the second thing is you can actually identify the turning points of any quadratic by just looking at that form here. So this x minus 3 minus 8. Now why is that? Well, if I write this out, the turning point is either the biggest value a quadratic can take or the smallest value. And because this is a positive x squared graph, you're going to expect it to be like this, which means this is going to be a minimum value. If I have a look at this, what is the smallest value this whole thing can be? Well, if I look at this bracket here could be any number from minus infinity to plus infinity. But I'm squaring it, which means this can actually never be negative. So this first thing here is always bigger than or equal to 0. The smallest thing that something squared can be is 0. Because think about it, if the bracket was minus 4 squared is 16. So it becomes positive again. Which, by the way, is why we have this curve up here where it goes back up. So if this pi is always bigger than or equal to 0, and then we're minusing 8, then that means this whole expression is always bigger than or equal to 0 minus 8. So in other words, the smallest value that y can be is negative 8. Okay, so that gives us one of the coordinates. Now we're just asking ourselves, at what value of x do we get y is equal to minus 8? Now what you could do is sub in minus 8 and figure it out, but I've got a quicker way to show you. How do we make this bracket equal to 0? Well, it's just when x equals 3. And if you'd like, you can check on your calculator now. If you sub in x equals 3, we get 3 minus 3 is 0. 0 squared is 0. Minus 8 is minus 8. So in short, all you're going to do is swap the sign of what's inside the bracket, and you keep the sign of what's on the outside the same. That's it. Cool. Let's try another one. Very similar. So once again, we're just going to put it into the form. So we're going to have a bracket, x. B in this case is 8, so we're going to half that to get 4. So we get plus 4 squared minus 4 squared, and then plus 5 on the end. Remember that plus c is always just chilling on the end. And let's simplify this. So we get x plus 4 squared minus 16 plus 5. So we get x plus 4 squared minus 11. Cool. And then again it says hence or otherwise find the coordinates of the turning point. Well, if you remember what I said, you keep the thing on the outside exactly the same. That's your y coordinate. And then you swap the sign of what's on the inside here. So instead of plus 4, it's going to be a minus 4. And that gives you like 3 marks in an exam. Really, really quick for that paper 1. Okay, let's look at some more interesting applications of this. So here we get show that x squared minus 6x plus 11 is bigger than 0 for all real values of x. Now, again, this is a completing the square video, so you know we're going to be completing the square, but let's think of the logic for a second. In the last two in the last two questions, we worked out the turning points for quadratics. In other words, we worked out the minimum value of y, or the minimum value that a quadratic can take. In this case, the smallest value a quadratic can take is minus 11. And in this case, the smallest value our quadratic can take is minus 8. So we can actually prove things are always positive by completing the square and seeing what the minimum value is. So if I complete the square of what's on the left, we get x. Half this number gives me minus 3 squared minus 3 squared plus 11. Then just expanding, that gives me minus 9 plus 11. Now we get x minus 3 squared plus 2. So if you notice, this thing is always bigger than 0. Why? Because look at the turning point. The turning point is 3, 2. Now, because this is a positive quadratic, this is the minimum point. If the minimum value of y is positive, that means the quadratic is always bigger than 0. In other words, it never ever crosses the x-axis. Or again, you can also say, this thing here is always bigger than or equal to 0, and then we're plussing 2, which means the overall quadratic is always bigger than or equal to 2, which means x squared minus 6x plus 11 is always bigger than 0 because it's actually always bigger than or equal to 2. So again, they might say, show that it's always positive, or show that there's no solutions, or they might say some other thing like that, and again, that's just completing the square. Okay, let's try something else quickly. This is an interesting one. We kind of have to work backwards. Now, how do I know it's completing the square? So again, in the last question, we know it's completing the square because we're asking about the turning point, because we said show that it's bigger than 0. So we're basically saying, what's the minimum value? Is the minimum value positive? If it is, it's always bigger than 0. Well, here, we get a quadratic and we don't know what a is or b. And it says, given that the minimum point of C has coordinates 4, minus 3, find the values of a and b. And they love to do this in exams. They don't want you just working forwards, they also want you working backwards. If they give you the minimum point of a quadratic, you can always use completing the square form. Now, how is this quadratic actually going to look then? Well, we're going to have x, that bracket's going to be squared, and then there's going to be something on the outside. Now, what was on the outside? The outside was always the y coordinate, so we know that it's minus 3 on the outside. And what about the inside? Well, it's not plus 4. Remember, we swap the sign when we make it the x coordinate, so that's going to be x minus 4 squared. Okay, how does this help us? Well, if I now expand the brackets, I'm going to get an equation that looks like this, and I can just compare to see what a and b are. Cool. So let's do it. We're going to have, if we expand this, x squared minus 4x is minus 8x plus 16 minus 3. So that gives us x squared minus 8x plus 13. So that is our value for b, and that is our value for a. A is negative 8, b is positive 13, and that's it. Okay. Now the last thing that we need to go through is when equations look like this. So what's the problem here? The problem is this value at the front. There is a coefficient of x squared. Now, if there is a number or something in front of x squared, it could be a negative sign, it could be positive 2, it could be a half, it could be 1/3, it could be negative 5, anything. We can't just apply completing the square straight away. Because if you look all the way back at the beginning of the video, it only applies when there's nothing in front of x squared. Okay, so what do we do now? Well, how can we make it so that there is no coefficient of x squared? Well, what I could do is factorize out the 2, right? So if I factorize out a 2, now do I need to factorize the last bit? Well, the last bit, if you again look back at the original equation, that just gets added on the end anyway. So why don't I just leave it out on the end? I'm just going to leave it chilling over here because it doesn't need to do anything yet. Well, now I could do completing the square with what's on the inside because now there's no coefficient of x squared. So again, the trick here is no matter what the coefficient is, you're going to factorize it out of the first 2 terms. Because when you do completing the square, it's only the first 2 terms that you care about anyway. So now when I do completing the square, I like to use big square brackets just to make it really clear. We're going to have x, and again we're going to half b, so that's going to be minus 3, squared minus minus 3 squared, and then there's no c in this case, the c is on the outside. So we're going to clean this up a tad. So minus 3 squared is 9, but then it's minus again, so it's minus 9. It's 23. Now we're going to expand just the square bracket. So 2 times that bracket gives me 2x minus 3 squared. And again, if we look back at the question, it says in the form a x plus b squared. So now we know that a is 2 and b is negative 3. 2 times minus 9 is minus 18, then plus 23. So we're still going to get x minus 3 squared minus 18 plus 23 is, 5. Wonderful. Now for part B, you might think that this might confuse things, but if you actually think about it for a second, does it actually change anything? The answer is no. Why? Because remember, to work out the turning point, I made this bracket 0. 2 times 0 is 0, it doesn't have any effect. So again, the turning point actually doesn't change even if there's a number in front of x squared. So you keep the number on the outside the same, so it would be our 5, and on the inside of the bracket, we flip the sign. There you go. The 2 has no impact on it whatsoever, even if it was a negative, positive, a fraction, whatever number it is. It could be a million if you wanted. It doesn't affect the turning point. When we do graph transformations, we'll explore why it doesn't do anything, but simply put, all it does is it stretches the graph. When you stretch something, it doesn't mean it changes the turning point. It doesn't change what 0 is. And that's it for completing the square. So hopefully you found that quite useful in terms of going through some of the exam questions. As a reminder again, in the link in the description, there are 2 links, one for Wednesday, one for Saturday for the free tuition classes. Again, there is no payment for that. If you want to join the actual kind of one-on-one or the group tuition, there's also a link there for you to book a free trial lesson too. But other than that, I'll see you in the next one when we go on to the next topic in quadratics.